Hi guys, this is Leah and we're going to practice working with the normal distribution. Let's try an example. At a bottling plant, the volume of ginger ale in large bottles is normally distributed with a mean of 2.01 liters and a standard deviation of 0.09 liters. Find the probability that a bottle contains between 1.89 liters and 2.14 liters of ginger ale. Let's let X represent the volume in a bottle, and that'll be measured in liters, and that volume is going to vary slightly from bottle to bottle. We're told in the question that the mean is 2.01 liters, so we'll write mu for the mean. Mu is equal to 2.01, and our standard deviation in symbols is sigma. Sigma is equal to 0.09. What we're looking to calculate is the probability that our volume, X, ranges between a couple of values. We want it to be between 1.89 liters and 2.14 liters. So in looking for this probability, we're really asking if it were possible to look at all bottles that were being produced, what percentage of them would have volumes between 1.89 and 2.14 liters. Now we're told in the question that the volume is normally distributed. So the volume X, we could say, is normal. X is normal. And that's going to allow us to change our X values into what are called Z-scores. So Z is equal to X minus mu over sigma. And just a caution here that this process of calculating Z-scores, that's only valid if you know that X is normal. So this is an essential assumption in the problem. Okay, well, let's turn our X values into Z-scores. Let's say Z1 is equal to 1.89. That's our first X value there, minus the mean, which is 2.01, and we'll divide by our standard deviation, which is 0.09. So if we plug that into our calculator, we get negative 1.33. And we'll take our second X value, turn that into a Z-score. So I'll call this Z2. We'll go 2.14 minus our mean divided by our standard deviation, and plug that into our calculator, we get 1.44. So what this allows us to do is change the variable in our probability statement. We're trying to find the probability that X lies between 1.89 and 2.14, and this probability here is equal to the probability that Z ranges through these values that we've just calculated. So probability that Z lies between negative 1.33 and 1.44. Now this probability is equal to area under the following curve. So I'm going to say it's equal to, and I'm going to draw what's called the Z curve. So this Z curve is centered at 0, and just as a point of reference, this value here would be about negative 3. That value there would be about positive 3. Now we're looking for the probability that Z lies between two specific values, so let's label those here. Let's say that's our value, negative 1.33, and 1.44 might be about there. So our probability is equal to the corresponding area under that curve. To calculate this shaded area, let's say that we have a Z table that looks like this. So let's imagine this is our Z table, and the diagram up the top here describes what sort of area our table gives us. So in this case, it gives us an area between Z equals 0 and Z equals some positive value. Now we'll first look through the rows of this table to find the leading digit and the first decimal place of our Z-score, and then after that we'll look across the columns to find the correct second decimal place. Now the Z values we calculated were 1.44, so the area corresponding to that would be this guy here. And our other Z value was negative 1.33, so I'm going to use the positive version of that, 1.33. We'll see why in a moment, and the area associated with that guy is this area here. So now going back to our calculation, we can think of our shaded area up here as really being the sum of two separate areas. There's one area that goes from z equal negative 1.33 up to 0, and then there's another one that goes from 0 to 1.44. One handy property of our z-curve is that it's symmetric. So if we look at the left side of our z-curve here, that's the mirror image of the right side. So to calculate our shaded area here, what we're going to do is break it up into two areas. We'll think of the first area as going from 0 to positive 1.33. So we're talking about that area there. And that really represents this area on the left side of our shaded area here. So we're using symmetry just to flip that over and represent it on the right side. And then we're going to add on the other part of our shaded area here, the part that goes from 0 to 1.44. Now, thanks to our table, we know what each of these areas are. From 0 to 1.33, we've got an area of 0.4082, and from 0 to 1.44, we've got an area of 0.4251. So adding these guys together, we'll have our final answer. Works out to 0.8333, or if we want to express that as a percentage, 83.33%. So the probability that a bottle contains between 1.89 liters and 2.14 liters of ginger ale, 83.33%.